So, hello guys. Cos theta to the power of 6. We want to use the Moivre's theorem, application of complex number, to break it down to a function of sine or cosine as a product of multiple angles. Now, please take note. This method we want to use to break this guy down is very, very essential even in calculus, especially integration. Why? Because if you are given a question like this that you are to integrate this, it is very, very complex. Except if you are to really use reduction formula. Reduction formula is meant for cos n theta, where n is greater than or equals to 2. Are we together? So, but even reduction formula is going to be long. But I prefer this to break it down using this De Moivre's application. You are going to see how beautiful it's going to be. Now, according to De Moivre's theorem, z equals to what? Using a unit circle plus what? I sine what? I sine theta using a unit circle. Our r, is r multiplied by this. So when we are dealing with a unit circle, our r is 1. So 1 times whatever we have here, we have. So let's find 1 over z. So 1 over z will give us what? Cos theta minus what? I sine what? I sine theta. You can prove it. 1 divided by this. If you rationalize and do everything, you will get this. Yeah, you will get it. Substitution of trig identity and everything. But just know this: 1 over z is the same thing, but the sign are different. This z is this, 1 over z is this. This is very correct under complex number. Now, according to De Moivre's theorem too, we have if z, okay, now let's add now. So now z plus 1 over z is going to give us what? Cos theta plus I sine theta plus what? Cos theta minus what? I sine theta. Assuming the question is sine, we are going to subtract to eliminate cosine. But the question is cosine. That's why we are having. We want to eliminate sine. I sine theta minus I sine theta cancel. So we have cos theta plus cos theta. So this guy gives us what? 2 cos what? 2 cos theta. That's z plus 1 over z. And don't forget the Moivre's theorem says if z plus 1 over z equals to 2 cos theta, then z raised power n plus 1 over z raised power n will give us what? 2 cos what? N theta. Do we remember? Now let's keep this. We don't need it here anymore. So here we have z raised power n plus 1 over z raised power n equals to what? 2 cos n theta. And what is our z plus z? Our z plus 1 over z equals to what? 2 cos what? 2 cos theta. Now let's take the sixth power of both sides. So z plus 1 over z all into power of 6 equals to 2 cos theta all into power of 6. Now, in this morning, I released a video on my general YouTube channel on how to do expansion very easy using the combination of binomial theorem and Pascal triangle. Now, let's expand this guy. We have z raised to power 6. Let me see whether that place is showing. Okay, it's showing. Yeah. We have z raised to power 6. Yes, it's showing. Plus what? Z raised to power 5. Then the second part will be power of 1. It was power of 0 here. Plus the first part now will reduce again, 4. The second part will be power of 2. Z raised power 2 all square is same thing as putting square here because 1 square is 1. Plus z cube 1 over what? Z cube plus z square 1 over what? Z4 plus z 1 over what? Z5 plus what? Z0 then 1 over what? Z6 equals to what? 2 raised power 6, 64. Then this we have what? Cos 6 theta. You can see that our question is showing again now. Our original question is showing. Now we need to get the question for Pascal triangle. Power of 0 is 1, power of 1, 1, 1, power of 2, 1, 2, 1, power of 3, 1, 3, 3, 1, power of 4, 1, 4, 6, 4, 1, power of 5, 1, 5, 10, 10, 5, 1, power of 6, 1, 6, 15, 20, 15, 6, 1. So this power is 1, 6, 15, 20, 15, 6, 1. So We are done with the expansion without stressing ourselves so much. So yeah, let's do justice to them. We have z raised to power 6 here. One z we cancel one here, we have 4 left here. So this guy gives us plus 6 z raised to power 4 plus 2z we cancel 2 here, we have 2 left here, plus 15 z square plus 15z square. Are we together? Plus this one we cancel plus 20 plus z square we cancel square here, we have 2 left at the denominator, plus 15 multiplied by 1 over z square. Here 1z we remove one here, we have 4 left here. We have plus what? 6 multiplied by 1 over what? Z4 equals to what? 64 cos 6 cos theta raised power 6 power. Are we clear now? Let's gather the lifetime together. Sorry. I'm not yet done. This equals 64 cos 6 theta. So there is one left, plus 1 over z6 equals to 64 cos theta to power of 6. Now, here we have z raised power 6 plus, join this one to it, 1 over z raised power 6. Now, this is z4 plus 6 is come, bring out 6. What do you have left here? Z4. Where are you having Z4 to here? Plus 1 over Z4. Bring it, 6 times this, you get this. 6 times this, you get this. Here you have Z squared plus 15 into Z squared. You can first gather them before you factor out 15, but there is no issue. Where do we have square here? Plus 1 over Z squared. 15 times this, you get this. 15 times this, you get this. What do we have left there? So we gather everything. We have 20 left. Plus 20 equals to what? 64 cos theta to 6th power. And don't forget the Moivre's theorem. If z plus 1 over z is 2 cos theta, then what did Moivre's theorem talk about? It says z raised to power n plus 1 over z raised to power n equals 2 cos n theta. This is not same thing as this. Here is the n, the power is outside. Here the power is inside. So here if you have z6 plus 1 over z6, what do we have? 2 cos 6 theta. So this guy gives us 2 cos 6 theta plus 6. This one will give us 2 cos 4 theta plus 15. This one will give us 2 cos 2 theta plus 20 equals to cos theta to power 6. The 64 here, we put it here, divided by 64. So this is the original question now. We've used 64 to divide both sides. Do we get? Now this is what we are going to do now. So here we are going to do something like 2 cos, we can split the 64 to each. If you have a plus b plus c over 2, the same thing as a over 2 plus b over 2 plus c over 2. So you can use 64 to divide this. 2 cos 6 theta divided by 64. 1 into 1. So here you have 1. 2 in 64 over 32 cos 6 theta. Plus, this is 6 times 2. We don't even need that. 2 here, 1. 2 in 64, 32. So this one will give us 6 over 32 cos 4 theta. This is 2 here, 1. 2 in 64, 32. This one will give us 15 times 1. We've used this 2 to cos 64. So there is 1 left. 15 times 1. We have plus 15 over 32 cos 2 theta. Plus 20 over 64. That will give us 10 over 32. Cos 2 in 20, 10. 2 in 64, 32 equals to what? Cos 6th power of theta. Cos theta to power of 6. So what is common to everything? 1 over 32, right? So here we remain cos 6 theta plus what? 6 cos 4 theta plus what? 15 cos 2 theta plus what? 10 equals to what? Cos 6 theta. We are done. This is what they ask us to do. So we've broken down. This is the final answer. That is equal to 6 power of theta. Now you can see that this is very applicable in calculus, very interesting, because in calculus, if you're asked to integrate, now if we are done with the question, but I'm just saying, assume it's calculus, integral plus integral plus integral plus the integral of this. The integral of this is equal to the integral of everything. Now, here 132 is constant. If you integrate cos 6 theta, you get 1 over 6 sine 6 theta times 1 over 32. That's the answer for that part. Plus 6 over 32 times 1 over 4 sine 4 theta plus 15 over 32 1 over 2 sine 2 theta plus theta, because this is a constant. If you integrate a constant, you get theta with respect to the theta. You get theta. That's very easy. Even me, I would prefer to use this de Moivre's theorem than reduction formula to integrate this guy. So that's that for that. Drop your view on the comment section. I want to see. So I hope that's very clear. Thanks for watching.